Hopefully you've realized that creating and counting the strings to find the nth Catalan number is not an efficient way to generate the series. However, it does give us confidence that a millionth Catalan number exists. We just have to count the number of strings made up of a million ones and a million zeros, where the initial segments always have more ones than zeros. We've done this already with the values of n from 0 to 4, and we could build a string of n equals a million with the same techniques, but it would take a terrifically long time. I'm not going to get you to build more strings to figure out how long it might take, but instead, we're going to have the computer do the work for us. I've created a first cat verb that actually generates the strings and then counts them to calculate the Catalan numbers. This is definitely not an efficient way of creating the Catalan series, but it does give a sense of how much work would be required. J also has a built-in verb called Timespacex that returns the execution time of the J sentence in seconds and the amount of memory required in bytes. We'll use this to see the amount of work needed as the values of n increase. These Timespacex results show us that time and space requirements increase far too quickly to get us much further than the 16th number in the series, even with computer assistance. It's obvious that we really need a different approach if we're going to find the millionth Catalan number. What would be nice is if there was a formula that provided the nth Catalan number directly without needing to create and count strings. Well, thankfully there is, and that formula is n choose 2 times n, all divided by n plus 1. Very nice, but before we use it, we should understand how it works, and we'll explore those ideas in the coming lessons of this lab. In the meantime, measure how FirstCat performs on your computer using Timespacex. It will give you a sense of how far your resources would get you if you tried to calculate the millionth Catalan number in this way. But start with numbers that are small, under 8, until you have a sense of the time and space requirements, or you could be waiting a very long time for the results.